Hi everyone. Now that we've learnt about the unit circle, we're going to have a look at some symmetry properties and also just some of the natural properties of the unit circle. Now, keep in mind from yesterday that our sine values were our y and our cosine values were our x values and our tan was our gradient. Okay, so really keep that in mind when you're working with the unit circle. What this does mean is that the unit circle just naturally has some properties in which certain quadrants have certain values which are negative. Okay, so if we had a look at quadrant 1, we're going to start in the top right and work anti-clockwise like we did last lesson. If we had a look in the top right quadrant, all of our x is positive and all of our y is positive. So what this means is that cosine and sine are both positive. And because they're both positive, our tan, naturally being a ratio of the two, is also positive. Okay, so in the top right quadrant, we have A for all, with all values being positive. Now, if we moved over to quadrant 2, being this one on the left, and we had a look at our x values, well, they're all negative, and our y values are all positive. Now, with our tan being a ratio of the two, that means that our tan, our gradient, is also negative. So that means that in the top left quadrant, quadrant 2, only our sine values are positive. The rest are all negative. Similarly, looking in the bottom left quadrant, our x values are all negative and our y values are all negative. But if we were to divide a negative by a negative, we'd end up with a positive gradient, so a positive tan. So in the third quadrant, tan is positive. And then in our fourth quadrant, lucky last, we have cosine being our positive because x is positive, y is negative, so our gradient, our tan, is going to also be negative. Now, if you'd like a little thing to help you remember, it's ASTC. So for all of us here in Victoria, that's all stations to Croydon, okay? If that just helps you remember which quadrant is which, always starting in the top right, okay? Now, because of this natural property of the unit circle, that means we end up with some symmetry properties. So if we had a look at just some angle theta, doesn't matter the size at the moment, we're just going to call it theta. Starting from the x-axis here, if I was to travel theta here, all of my exact values are going to be positive. So sine, cosine, and tangent, because they're all in the first quadrant. If I was to, let's say, start from pi and go backwards to here, then we'd have a bit of a different story because we're in the second quadrant. So if I go from pi and I take away an angle, I'm going to end up with only my sine value being positive and none of the rest. Okay? So that means we end up with a nice little property of sine pi minus theta is still equal to theta. Whereas for cosine and tangent, that's actually going to be negative theta, okay? Oh, sorry, the sine of theta. Apologies. Now, if let's say I was to start at pi and go forward, we'd end up in our third quadrant, which is tan. So that means tan of pi plus theta is equal to tan of theta because it's still positive, all right? And then if let's say I was to start at 0 or 2 pi and go backwards, I'd end up with cosine 2 pi minus theta is equal to the positive cosine of theta, okay? So it's really just a matter of what's my angle? If I travel from a certain spot, where do I end up, okay? But we do have some really key symmetry properties just here, all right? And just think of it, if you were to draw that out, if we had some theta of some kind, and I'm always starting on my x-axis and going backwards, that only cosine is positive here, okay? So that means that cosine would just be equal to cosine of theta, but then sine and tangent of negative theta is going to be equal to the negative of the sine of theta because we end up in that fourth quadrant, okay? So feel free to pause here and have a go by yourself, but I'm also going to go through them. Now, sine 270, I'm going to draw a nice, neat little unit circle here, okay? 270 degrees. Oh, you wouldn't be able to see that. There we go. 270 degrees, I'm going to end up here, okay, because I've gone 180 plus the 90. And we can see without actually having to do any calculations that the sine of 270 would be -1, okay? Now, we're going to do that again, but instead of looking at 270, we're going to look at 5 pi on 2. Now, keep in mind that 5 pi on 2 is also equal to the cosine of 2 pi plus pi on 2, because 2 pi is equal to 4 pi on 2. So if I've already made it around once, and then I go pi on 2 further, I'm going to end up here. And we can see that that is equal to 0, because our x value there is 0. Now, cosine of -180 is starting from here and working this way. I'm going to end up on the opposite end, and I can see that that is -1. Sine 13 pi on 3. If I was to try and simplify that a little bit, I would see that I've got 4 pi's there, and I've added on pi on 3. Because I've got 12 pi on 3, I'm going to add on pi on 3. That means that we're going to be equal to the sine of pi on 3, which hopefully we remember from before is √3 on 2, but feel free to have your triangles or your table out if needed. Now, tan 7 pi on 4, I can see that that is equal to tan 2 pi take away pi on 4, which means that we're going to end up in that fourth quadrant right there, and I'm going to end up with negative tan pi on 4, which hopefully we remembered that pi on 4 for tan is 1, so that means we've got -1. And then same sort of idea for this one here. 11 pi on 6 is the same as saying 2 pi take pi on 6. So we're here, we've taken away pi on 6. That means I've got the negative of sine pi on 6, which is -1/2. Now, we can apply these symmetry properties when we only know just a sort of random number, not necessarily an exact value, but just a random number. And the beauty of these kinds of problems is that usually your answer is just going to be a positive or negative version of whatever your original value was. When attempting these sorts of problems, it's best to just draw out a unit circle and see where you end up, yeah? So if I'm at pi minus x, that means that I have started at pi and I've gone back. Okay, it's really just a matter of what quadrant have I landed in. I've landed in quadrant 2, which means that sine is positive. So this is equal to 2/3. Same idea. I've started here, but we're starting at pi and going forward, where sine is actually negative. The answer would be -2/3. For these ones here, if I start at 2 pi, that's the same as starting at 0. And then I go backwards, I'm going to end up in the fourth quadrant, which we know is -4 sine. And then last one, essentially what we just did, I'm starting here and going backwards. I once again end up in that fourth quadrant at -2/3. Now, for this one here, once again, same idea. Have a look at which quadrant you end up in. So doing negative theta, I'm going to end up in the fourth quadrant, meaning that I'm going to have negative sine of theta, which is -0.588. Looking at 3 pi plus theta, I know 3 pi is going to be here. And then plussing on an angle, I'm going to end up in that third quadrant, which is where sine is once again negative. Now, same thing here. 2 pi is going to be here. If I go backwards an angle, I'm going to end up in the fourth quadrant, where sine is once again negative.